figure below is a map of a forest drawn on a grid of 1 centimeter squares. A. Estimate the area of the map in square centimeters. B. If the scale of the map is 1 to 50,000, estimate the area of the forest in hectares. Complete the table below for the function y is equals to 3x squared minus x plus 10. Using the values in the table and the trapezoid rule, estimate the area bounded by the curve y is equals to 3x squared minus x plus 10 and lines y is equals to 0, x is equals to 0, and x is equals to 10. The graph shown consists of a non-quadratic part between 0 and 2 and a quadratic part between x is equals to 0 and 8. The quadratic part is y is equals to x squared minus 3x plus 5. A particle is projected from the origin. Its speed was recorded as shown in the table below. Use the trapezoid rule to estimate the distance covered by the particle within 35 seconds. The table below shows values of x and the corresponding values of y for a given curve. Use the trapezium rule with 7 ordinates and values in the table only to estimate the area enclosed by the curve x-axis and the line x is equals to pi over 2 to 4 decimal places. Take pi to be equal to 3.142. The exact value of the area enclosed by the curve is known to be 0.8940. Find the percentage error made when the trapezium rule is used. Give the answer correct to 2 decimal places. A circle center O has the equation x squared plus y squared is equals to 4. The area of the circle in the first quadrant is divided into 5 vertical strips, each of with 0.4 centimeter. Use the equation of the circle to complete the table below for values of y correct to 2 decimal places. Use the trapezium rule to estimate the area of the circle. The diagram on the grid below represents an extract of a survey map showing 2 adjacent plots belonging to Kazungu and Ndoe. The two dispute the common boundary, with each claiming the boundary along different smooth curves. Coordinates x, y1 and x, y2 in the table below represents points on the boundary as claimed by Kazungu and Ndoe respectively. On the grid provided above, draw and label the boundaries as claimed by Kazungu and Ndoe. Use the trapezium rule with 10 strips to estimate the area of the section of the land in dispute. Express the area found in B1 above in hectares, given that 1 unit on each axis represents 20 meters. Using the trapezium rule with 7 ordinates, estimate the area of the region bounded by the curve y is equals to negative x squared plus 6x plus 1. The lines x is equals to 0, y is equals to 0, and x is equal to 6. B. Calculate the area of the region in A above by integration. B2. Percentage error of the estimated area to the actual area of the region correct to 2 decimal places. On the grid, draw the graph of y is equals to 4 minus a quarter x squared for values of x between negative 4 and 4. Using the trapezium rule with 8 strips, estimate the area bounded by the curve and the x-axis. C. Find the area estimated in part B above by integration. Calculate the percentage error in estimating the area using trapezium rule. The shaded region on the graph shows a piece of land ABCD earmarked for building a sub-county hospital. Use trapezium rule with 6 strips to estimate the area of the piece of land ABCD in hectares. The diagram below is a sketch of two curves y is equals to 2x squared plus 1 and y is equals to x squared plus 1 drawn on the same grid. Using the trapezium rule with 5 strips, estimate the area bounded by the curves. Y is equals to 2x squared plus 1, y is equals to x squared plus 1, and the lines x is equal to 0 and x is equal to 5. The equation of a curve is given by y is equals to x squared. Using the trapezium rule with 4 strips, estimate the area enclosed by the curve y is equals to x squared and lines x is equals to 1, x is equal to 5, and the x-axis. The table below shows some values of the function y is equals to x squared plus 2x minus 3. A. Complete the table. B. Using the completed table and the mid-ordinate rule with 6 ordinates, estimate the area of the region bounded by the curve y is equals to x squared plus 2x minus 3 and the line y is equals to 0, x is equal to negative 6, and x is equals to negative 3. C. By integration, find the actual area of the region in B above. Calculate the percentage error using calculate the percentage error arising from the estimate in B above. The diagram below is a sketch of the curve y is equals to x squared plus 5. A1. Use the mid-ordinate rule with 6 strips to estimate the area enclosed by the curve, the x-axis and the y-axis, and the line x is equals to 3. 2. Calculate the same area using integration method. B. Assuming the area calculated in A2 is exact, calculate the percentage error made when the mid-ordinate rule is used. The table below shows some values of the function y is equals to x squared plus 3. Complete the table. Use the mid-ordinate rule with 6 ordinates to estimate the area bounded by y is equals to x squared plus 3 and y-axis and x-axis, and the line x is equals to 6. The table below shows some of the values of x and y for the function y is equals to a half x squared plus 2x plus 1 in the interval between 0 and 6 for x values. Use the values in the table to draw the graph of the function on the grid. B1. Using the graph and the mid-ordinate rule with 6 strips, estimate the area bounded by the curve, the x-axis, the y-axis, and the line x is equals to 0. 2. If the exact area of the region described in B1 above is 78 centimeters squared, calculate the percentage error made when the mid-ordinate rule is used, given that give the answer correct to 2 decimal places. The figure below is a sketch of a curve whose equation is y is equals to x squared plus x plus 5. It cuts the line y is equals to 11 at point P and Q. Find the area bounded by the curve y is equals to x squared plus x plus 5 and the line y is equals to 11 using the trapezium rule with 5 strips. Calculate the difference in the area in the if the mid-ordinate rule with 5 ordinates was used instead of the trapezium rule. On the grid, draw a graph of the function y is equals to a half x squared minus x plus 3 for values of x between 0 and 6. Calculate the mid-ordinate for 5 strips between x is equals to 1 and x is equals to 6. Hence, use the mid-ordinate rule to approximate the area under the curve between x is equals to 1, x is equals to 6, and the x-axis. Assuming that the area determined by integration to be actual area, calculate the percentage error in using the mid-ordinate rule. The figure below represents the curve of an equation. Use the mid-ordinate rule with 4 ordinates to estimate the area bounded by the curve lines y is equals to 0, x is equals to negative 3, and x is equals to 5. Use the mid-ordinate rule with 6 strips to find the area bounded by the curve y is equals to x squared plus 1, the line x is equals to negative 4, x is equals to 8, and x-axis. The shaded region on the graph below shows a piece of land A, B, C, D, earmarked for building a sub-county hospital. Write down the ordinates of curves A, B, and DC for x is equals to 0, 200, 400, 600, 800, 1,000, and 1,200. Use the mid-ordinate rule with 3 strips to estimate the area of the piece of land in hectares. The diagram below is a sketch of 2 curves, y is equals to 2x squared plus 1 and y is equals to x squared plus 1, drawn on the same grid. Using the mid-ordinate rule with 5 strips, estimate the area bounded by the curves y is equals to 2x squared plus 1, y is equals to x squared plus 1, and the lines x is equals to 0 and x is equals to 5.